All right, hi Math9 students. We're going to do the recording now for the rewrite test. It's going to be on Thursday. And so I'm redoing a lot of the questions we went over before, but also doing some new ones this time. And I'm going to do some of the questions in a slightly different way. I took a fair amount of time to rewrite these questions, try to make them a little better. And so hopefully that comes through and you find them a little easier to understand. So we'll go to the first question here. I don't know if you guys love soccer, but I totally do. I really like watching hockey, but I prefer playing soccer. Any of you guys that came out to, well, I guess you guys anyways, came out to the Campo, right? And I totally love playing soccer with Austin. He loves it too. Anyways, so in any kind of sport, a substitute is a player that takes the place of another player, right? Yeah, totally, eh? So basically what happens, what we're talking about with substitution is you're plugging in a number for each variable that you see, right? That's called substituting, plugging in the number. So what we do then is you can see here's the expression, the math expression, right? And so every time you take an x, since it says if x equals -2, then this whole expression is equal to, all we need to do is plug in the -2 every time you see an x. It's basically that simple, right? You can put brackets around it if you like, because that reminds you that you're multiplying the number 4 times the -2. But you can see that all we've done here is taken each one of the x's and put in a -2, right? Okay, so now if we simplify 4 times -2, that's going to equal -8, right? Now the -2 squared is the same as -2 times -2, right? And that's just going to equal 4. So here you have 5 times 4, which equals 20. So you can see the simplification we've done on both parts of this, you could say, these two parts. And now we have -8 plus 20, and that's going to equal plus 12. Okay? So I'm hoping that makes sense. And again, guys, please stop me if anything's not making sense, okay? And I'm going to go through this stuff fairly quickly, but again, stop me at any point if you need to. So this question says, what's the value of this expression as a decimal? Okay, so first of all, we need to simplify these two numbers. Now, simplifying numbers basically just means find out what they are. You know, find out what the answer is for those numbers. So we're going to simplify 2 squared and 4 to the -1, and then we can add whatever they equal. So I'm just going to ask you guys some questions, and you know, feel free. If you know the answer, type it out. If you don't, that's okay. We'll just kind of roll with it. But what is 2 squared equal? What does that part equal so far? Okay, 2 squared equals 4. Good. And so we'll go to the next page. So we know 2 squared is 2 times 2 or 4. How about 4 to the -1? You guys remember what the rule is when you have an expression with a negative exponent? There's 2 steps that we always take. Okay, so the first step is we take the power with a negative exponent, so that's 4 to the -1, and we just make it into a power with a positive exponent. So we take away the -1, and it's 4 to the 1. Okay, that's step 1, or I made it step A here. Okay, the second step is divide 1 by this power. So instead of having 4 to the 1, we have 1 over 4 to the 1. Okay, so those are the 2 steps right there. Take the negative exponent, make it into a positive exponent. That's step A. Step B is divide 1 by that positive power. Okay, so we have 1 over 4 to the 1 after those 2 steps. Okay, so now all we do, 1 over 4 to the 1 is just the same as 1 over 4, right? And so then we need to make it into a decimal because we're wanting to add this number to the other number. So 1 over 4, we just do it on our calculator, and we get 0.25. So now let's see what we have so far. Okay, so we took 2 squared and we made that into 4. We took 4 to the -1, and eventually that became a decimal as 0.25. And then we just add 4 and 0.25, and we get 4.25. Okay, so does that pretty well make sense, guys, what we did there? Okay, right on. Good stuff. So we'll go to the next screen. So we're just talking about puzzles. I don't know, do you guys like puzzles? I know there's all different kind of puzzles, right? There's like Rubik's Cubes and stuff like that. When I was in junior high, there was a guy in Kitchener, Ontario who just came over from, I think it was Thailand, and he was able to solve a Rubik's Cube in something like 12 seconds or something like that. Like he had one of the world records, and he went to my sister's junior high. So this guy was pretty amazing. Yeah, I could never do that thing. I don't think I ever will. But yeah, puzzles are pretty cool. And I know Christmas time, my wife's family likes to take the puzzle out, 1,000-piece puzzle, and everybody kind of works on it over Christmas. So anyways, this question here is talking about, in a math puzzle, you have 3 consecutive odd numbers, right? Okay, so what are consecutive numbers again? Those are just 1, 2, 3 kind of thing, like one number after another. And since they're consecutive odd numbers, it's 3, 5, 7. That would be an example, right? Okay? Now, that's just an example. The 3, 5, and 7 have nothing to do with our question. It was just to show you what 3 consecutive odd numbers are. Okay, so this question says, what are 3 consecutive odd numbers whose sum is 219, and what's the value of the largest number? Okay, so we'll just kind of tuck that away for now. And for now, we're just going to explore a little bit more about this example with these 3 numbers. So if these 3 were 3 consecutive odd numbers, it's important to note that the average of the 3 consecutive numbers is the middle number. Okay, so if you take the average of these 3 numbers, remember how you get an average, you add the 3 numbers together, okay, like this, and then you divide by 3 because there's 3 numbers. Okay, so you're going to have 15 divided by 3, and that's 5. Okay, so when we're taking the average of these 3 numbers, that average always turns out to be the middle number if there's 3 numbers. Okay, so that's going to help us to continue on with the problem here. Okay, so back with this particular problem. So if we can find the average of 3 consecutive numbers that add up to 219, then we'll know what the middle number is. Once we know what the middle number is, we can find what the one below and the one above. Now this question is actually asking what's the largest number. Okay, so that's the number above. So again, we use that formula. The average is the total of the 3 numbers divided by 3. So here we have 219 as the sum. That's in the question, it's told. We divide by 3. So we get 73 as the average. Okay, so here's how we find the number above and below. So the average number is 73. The one below is average minus 2, okay, because again we're talking odd numbers, right? So they go up by 2. So this one's going to be 73 minus 2, which is 71, whereas the one above is going to be 73 plus 2, which is 75. Okay, so does that make sense how we got those 3 numbers? And then since the question's asking what the largest of the 3 is, you can see it would be 75, right? Okay, good stuff. So that's how you do that one. And going on to the next one, okay, this one says this expression here is equivalent to, all right, so we got to find out what it equals. We got to use those rules of exponents, right? Okay, so here's a question for you guys. So when we have an exponent inside a bracket and an exponent outside, what we do is we need to multiply the exponent inside times the exponent outside, right? Okay? So what are we going to get if you just look at the bold text here? What do we get when we do the multiplication? So we're just simplifying this part of the problem right now. And if you want to show an exponent, remember you can use those little hats. By hat, I mean, like let's say you wanted to do a to the power of 3, okay? That little kind of arrow thing is like a hat, okay? So you can use that to show what it would be. What would it be right at this point? N to the power of what? Okay, that's right, n to the 6. Good, so that's what we have at this point. And now let's go on. Okay, so at this point we now have n to the power of 6 instead of what we started with on top. Now we still continue. And what's the rule for dividing powers whenever they have the same base? And what I mean by that is, what do we do to the exponents? We're going to do to these 2 exponents. Add, subtract, multiply, divide. Okay, well remember the rule is when you divide two powers that have the same base, you're going to subtract the exponents. So we subtract 6 minus 2. Okay, so what it's going to look like when you have 6 minus 2, remember when you have two minuses in a row, it's just a plus, right? So we can now write n to the power of 6 plus 2, and that's just n to the 8. Okay? So just remember that. The rule for dividing powers, we subtract exponents when we divide powers. The part about the two minuses, yeah, there's a lot of those kind of rules in math, eh? Sometimes I tell students it's kind of like two wrongs make a right, although normally that's not true, right? But it's kind of like in math they do. It's like two negatives make a positive. So, yeah. Okay, so this one here, you've got something on top and something on bottom, right? So when you simplify this, by the way, I was going to ask you guys, are you guys into the Oilers at all? I know right now they're not giving us much reason at all to be into them. They're like just barely above last. Oh yeah. Yeah, it's definitely becoming a little more difficult to be an Oilers fan these days. So I'm kind of swinging over the Canucks myself right now. I haven't totally abandoned them, but kind of looking long term, you know. Yeah. All right, so what we want to do here then, we want to simplify what's on top and what's on bottom, right? So once we simplify what's on top and what's on bottom, then we divide what we get on top by what's on bottom. Okay, so let's do that. And so when we simplify what's on top, remember we're doing the same thing. We multiply the exponent inside the bracket times the exponent outside, and 2 times 3 is 6. Again, x to the 6. Now how about this here? We have x to the power of 4 raised to the power of 0. So this whole thing is kind of like a base, right? And it's raised to the power of 0. So guys, what does any base raised to the exponent 0 equal? That's right, it equals 1. And in the lesson, I even said something about, you know, 5 to the 0 equals 1, even like hamburgers to the power of 0 equals 1. You know, whatever, right? Okay, so you guys got the idea. So that's going to equal 1, that whole thing. So how it all kind of spills down now at this point is this here, what we had on top equals x to the 6, what we had on bottom equals 1, and x to the 6 over 1 is the same thing as just x to the 6, right? So that's going to be our answer. Okay? So that's how we do that one. All right, good old cross multiplying. So this one here, we've got an equation, right? And we want to solve it. And whenever we have two fractions equal to one another, and there's a missing variable in there, we can find that missing variable by cross-multiplying. So again, all cross-multiplying means is multiply the bottom of one fraction by the top of the other, and then again, bottom of one by the top of the other. And so I just want to ask you guys, what is the equation we're going to end up with when we do that? And so if you want to write the equation, write it so you've got some sort of x term on the left. We usually like to put x on the left, and some sort of y term on the right. Can someone tell me when we do the multiplication what the x term will be on the left when we multiply the two things together? Okay, well it's going to be 5 times x, which is just 5x, right? Okay, and how about on the right side? What's going to be on the right side? It's going to be these two multiplied together, right? 27. Okay, so let's see that. So 5x on the left and 27 on the right. So now we've got a little mini equation. And so how do we solve this equation? How do we get rid of this 5 again, guys? We've got 5 times x. We need to get rid of the 5. What's the opposite of times 5? Come on, don't be shy, my friends. I know I'm asking a lot of questions here. Okay. Okay, so the opposite of times 5 is divided by 5, right? Times and divided are kind of the opposite. And so we divide both sides by 5, and that'll get rid of the 5 on the left. So 5x divided by 5, that's going to give us just x, because the 5's cross out, right? Whenever the same thing on top and bottom, you just cross them out. So we got x on the left, and on the right we have 27 over 5. Plug it into your calculator, and you get 5.4. Okay, so that's how you do that one. You should see some of the accents my daughter does. They're pretty cool. She always does this one when she's around my dog, and I don't know if I'll even try it, but it is very funny. So maybe I'll record it and get her to do it. I will seriously do that. I will get her to record it on the computer, and I will send it over. By the way, speaking of dogs, yeah, I love accents. I love all kinds of Scottish accents and Irish accents and all that stuff. I guess you were talking to Mrs. Homolde, right, Ariel? I don't know if you've had a chance to meet her yet, Matthew, but yeah, it sounds like she might possibly be getting a golden retriever like us, which is kind of cool. I love our golden retriever. Caramel. Anyways, let's go on here, guys. Next question. Yeah, we got a fair amount of stuff to cover. Okay, I better put it into hyperdrive here. Okay, if I want to buy a cell phone for Christmas, I must pay 30 cents per minute for each local call I make, plus a monthly fee of 45. What formula would give the phone cost for 1 month if C is cost in dollars and X is the number of minutes that I spend on the phone? Okay, so we make C equal to the total cost. Now we have to pay $45, sorry, each month plus something else, and we need to figure out what that something else is. So we're going to write down what the equation looks like so far. So far, since C equals total cost, the part that we know so far is that C equals $45 plus something else, and that's the part we need to figure out. So let's figure out the question mark part, the rest of it. Okay, well, we know that X stands for the number of minutes. Okay, that's what it says in the question. Now we need to multiply the number of minutes we spend on the phone times the cost for each minute, right? And it tells us in the question it's 30 cents per minute. Okay, so we're going to change that into dollars because we already had dollars before, right? So we're going to change that into 0.3. So 0.3 times X is the rest of the cost. Okay, so the first was the $45, and now the rest is going to be 0.3 times X. Okay, so the formula we use then is going to be $45 plus 0.3 times X. Okay, you got this amount that's like a fixed amount, and this is what's called a variable amount. Okay, so that's going to be our formula. And I'll just kind of move on, guys, okay? So this here is talking about the highest dive being 172 feet, and I was just mentioning before that somebody has had a higher dive than that, but the rules are you have to be able to walk away under your own power, and so that guy didn't, so it didn't count. All right, so this question says, a diver steps off a diving board, time in seconds it takes her to hit the water is related to distance in meters, which is D, and the formula we use is D equals 4.9 T squared. Okay, so it says it takes the diver 0.6 seconds to hit the water. And what we're needing to find is the distance. Okay, so we know time, we need to find distance. And we're going to have to do some rounding here. Okay, so we need to find distance. So I said in the formula, D is distance, T is time. Now if we switch 0.6 seconds for T, again substituting, just like that first question, then we can find what D is, right? Okay, so then what are we going to put in for the blank here? If we have D equals 4.9 something squared, it's going to be 0.6 squared, right? Because we're putting that in for T. Okay, so now we'll show what that looks like. Okay, so instead of the T, we just put in the 0.6, and 0.6 squared is 0.6 times 0.6. That's 0.36. We multiply it by the 4.9. We get this amount here. Now again, it says we need to round to the nearest hundredth. Okay, so this is tenths, this is hundredths. So we need to look to the thousandths digit to help us round to the hundredths. Because it's 4, we just keep it at 6. If it was 5, we would round to 1.77, or if it was higher than 5. Okay? So the number rounded to the nearest hundredth is 1.676. All right. So that's that one. Here's just a little cartoon. He says, I'm having difficulty adjusting. The last place I worked at was bigger. So he's got this thing just ramming all the cars into the ceiling. Not good for business. All right. So this question says, 2 companies advertise the following labor costs for car repair. So we've got A1. This here is their setup, Classic, and this is their setup, their fees. Now it says if a particular repair takes 6 hours at A1 but only 5 hours at Classics, how much money would a customer save by going to A1 car repair? So what I want to ask you guys is just some questions that will help us kind of focus on this. So what formula would we use to find the total cost at A1? Okay, well that's going to be the cost per hour times the number of hours plus $40 automatically, right? Does that make sense? That's the formula we're going to use for A1. It's going to be the same kind of formula for Classics, right? And the next question says, what formula do we use to find the cost of savings? What do you guys think? Yeah, exactly. So we're going to subtract the more expensive amount, the larger dollar amount, minus the smaller amount. That's going to be the cost of savings. Yeah, totally, right? Okay, so we just kind of got that tucked away in our mind. So here's how we actually find the cost of A1. Again, we multiply the cost per hour times hour plus that $40. We get this amount. Same thing for Classics. Then we just subtract the larger amount minus the smaller, and we get the amount of savings. Okay? So that one's not too bad, eh? All right, so this picture here, we got some skydiving. Something I don't think you'll ever find me doing. I don't know, how about you, Matthew? I know you want to become or you thought about possibly becoming a pilot someday. Would you do some skydiving? Yeah, I don't think I would either. And now these guys here are doing this, and again, I don't know if this is a real picture or just something someone made up. I really have no clue if you can do this up in the air. But I thought it was kind of cool, so I just thought I'd put it there. Sky surfing, eh? All right, so next question says, a parachutist jumps out of a plane that is flying at an altitude of 4 kilometers, and then she immediately opens her parachute. If she falls at an average rate of 16 meters per second, she will reach the ground in. Okay, so we notice here we have some different amounts. We have kilometers and we have meters, right? So we know somewhere we're going to have to convert from one to the other. And whenever you have something like distance, and then you also have a speed, you figure you're probably going to have to set up a ratio somewhere along the line. Okay, so we need to find out how long she's going to reach the ground in 4 kilometers when she travels that distance. We know that she travels 16 meters in 1 second. We want to know if she goes 4 kilometers or 4,000 meters, how many seconds it's going to be. Okay, so we're going to set up a ratio. So what we do always is, first of all, we write a sentence. So if you wrote the sentence, you would say she falls 16 meters in 1 second. Okay, that you can pull out of this. And then you say she falls 4,000 meters in X seconds. So that's what we need to find, the X seconds. Okay, so now we set up our proportion. So we put this on the top, this on the bottom, on one side of the equation, this on the top, this on the bottom, on the other. So again, just like before, we cross-multiply whenever we have a situation like this. So we have 16x, and we write that here, and then we're going to have 4,000 on the right side. So again, just like before, we need to get rid of the 16. We divide both sides by 16, and we end up with x equals 250 seconds. Okay? So, did that make sense, guys? I'll just kind of roll with it for now and again, stop me if you need help with something. Okay, so the next one here, you can see here that you have like digit times power of 10 times digit times power, or decimal times power of 10. So I coded them in colors so that would help you to kind of keep track of them. And so the easiest way to do this multiplication is to multiply decimal times decimal. You can see that here. You end up with this. And then you multiply power of 10 times power of 10. Now just as before, we know that when we multiply powers of 10, we add the digits, right? And so when we add 5 plus minus 2, it's the same as 5 minus 2, which is 3, 10 to the power of 3. So you can see that these are the two things you end up with. So this here could be your answer, possibly. They might want you to actually do the multiplication and see that this is 1,000 times 16.2 and see what that big number is. Or they might say, give me the answer in scientific notation. If you do that, then you need to take this number here, and you can figure out this number in scientific notation. Because remember, first you make it, you put the decimal in a place that creates a number between 1 and 10, and then you count the number of digits that come after that, which is going to be 4. And that's why it's 1.62 times 10 to the 4. Okay? That's just a little review of scientific notation. All right. So this one here, to do this here, what you basically need to do is you need to take the amount of the square root of 44 and find out what that is. So it's just like, bang, that's 12, right? And then you take this amount, minus 3.6, times minus 3.6, right? You just figure that out, and that's going to be 12.96. Okay, so we just figured out this amount and this amount. So, oh, that's the next question. So what we've done so far is I just took this amount under the square root, I put it in red, I put this amount in red, and then I brought the negatives down. Okay? We didn't deal with the negatives before because we were only dealing with the other parts of the number. So now we just bring the negative down and bring the negative down. I've got minus 12 and I've become even more negative. It's like I was, negative temperatures, even more negative, and now I have a big negative number, minus 24.96. Okay? So, let's go on to the next one. Excuse me. Next one's kind of cool. What I always like to do, guys, is I like to take a more complicated problem and make it more simple if I can, or just kind of explain it in a different way that makes a little more sense. So this is talking about a cargo plane being loaded, and it talks about the total volume of storage space in the plane being this large amount, and then it talks about the volume of just one crate on the plane. And it says how many crates will fit in that total volume of storage space. Okay, so basically what you're doing here, whenever you want to find out how many of something small fits into something large, we're going to divide, right? So, for instance, if you had these 6 green cubes and these 2 blue ones, and you wanted to find out how many of the blue ones divide into the green ones, you just divide 6 by 2. And you'll see that you get 3 of these blue ones. Okay? So here we're just dividing the number of green by blue, 6 over 2, and it gives us 3. Okay, so that's just kind of giving us an idea of how we're doing this problem, right? It's kind of got more complicated numbers, but that's the basic idea. What we're doing, instead of using those cubes, we've got the total volume of the crate, and that equals this number, and we've got the volume of one crate, and that's this number. If we want to find out how many of those one crates divide into the total volume, we just divide this big number by the small one, and that'll give us the number of crates, just like it did in the other problem with the cubes. Okay. Did you just have to do something there, Ariel? Okay. All right. So hopefully this makes sense then. The number of crates, good. Number of crates equals the total volume of the crates, or of all the crates, divided by the volume of one crate, right? Okay, and when we do the math, we're going to divide these numbers out. Okay, and again, we can use exponent rules to divide these out if we want, or we can just make this into 1,000, this into 10. We can divide it that way. Okay, so here's what it looks like then. I just did it that way. I did the exponent rules and I got this amount. I divided these numbers and I got this amount. So we get this as an answer, 1.2 times 10 squared. And you know, the answer, or rather the question might ask you for a number like, you know, is it 50, is it 70, is it 120? Well, this would be 120 because you would multiply 1.2 times 100 and that gives you 120. Okay? So that's how we do that one. And okay, the next one here is an equation, right? And we know when we solve any equation, our overall goal is to get some variable like x on one side and a number on the other side. Okay, so that's what we're working towards, right? But guys, if you look at this particular equation, what is our first step going to be? When you've got a smaller variable like 2x and a larger variable like 8x, what's the first step you want to do in solving that sort of equation? I'll give you a hint. You want to get rid of one of those guys, one of those variable terms, because we want to end up with just one variable term. But which one do you think we want to get rid of? The small one or the large one? That's right, because if we subtracted 8x from both sides, we're going to end up with a negative 6x on the left. We don't want a negative, so we get rid of the smaller one. Good stuff. All right, so that's what we're going to do. So you can see here, we want to get rid of the 2x. You can see I'm subtracting 2x from both sides. And when I do that, there's no x's that are left on the left side. We have 6x on the right. So this is our equation at this point. So any idea, guys, what step we're going to do at this point to simplify things? Remember, we want to end up with just x on the right. So what do we want to get rid of on the right side right now that's there? Okay, we're going to want to get rid of this minus 34. So we get rid of that first. So we're going to add 34 to both sides. So here we go. There we're adding 34 to both sides. On the left, we're going to end up with 48. These numbers cancel out, and we're left with 6x on the right. Okay, so now at this point, I can ask you what we're going to do. Well, we've kind of gone over this stuff before, right? It's like if we have 6x, what do we divide both sides by? We're going to divide by 6, right? So that's going to be our last step. Okay, so there we are dividing by 6, and we end up with x equals 8. Okay, so that's kind of the way we reason through those steps when you have that equation where you have two different variables. Okay? It's kind of broken into parts. So again, review all this stuff and make sure you can get all these questions. All right, so now we're going to talk about algebra tiles. And remember that shaded stands for positive, unshaded is negative, right? So the first thing I want to ask you guys is, with that in mind, remember these little squares stand for numbers. Okay. All right. Well, let's give it a shot here. And so the little squares stand for numbers, and remember the rectangles stand for x's, right? X or minus x. So the first thing we want to figure out, it says which of the following products, okay? So products means you're multiplying two things together. So you're multiplying these things together. Which of those products is going to be represented by this model here? So the first thing we can do is figure out what is this model here, right? So what do you guys think? What does this model stand for? What are these four things going to stand for? Okay, and remember that these are minus, right? The unshaded ones are minus, and each one of them is a minus x, so it's going to be minus x times 4 of them, so it's going to be minus 4x, right? And then it's actually going to be plus 16, because remember the shaded ones are positive, right? So it's going to be minus 4x plus 16. Does that make sense so far, guys? Okay. Okay, so that's what we have so far, and I'll show that on the next screen. Good stuff. So I made a mistake here too. I should have said minus 4x plus 16. Okay, and hopefully you can kind of see that. Okay, so that's minus 4x plus 16, and again, I'll just put it here. Okay, so there's a minus 4x. Okay, so now what we do, guys, is we need to do each one of these multiplications and see which one of these multiplications gives us minus 4x plus 16. Okay, so if we multiply 4 times minus x, it gives us minus 4x, right? Well, if we multiply 4 times 4, that gives us 16. So, wow, that one was too easy, right? We just found it right off the bat. It's not always quite so easy. But if you multiply the other ones, you can see why it doesn't give you minus 4x plus 16, right? Because this one gives you 4x. Oh, well, okay, I'll write off. Sorry, what was that, Ariel? You're wondering what I said up here beside A? I was just saying that 4 times minus x gives us minus 4x, and then 4 times 4 is 16, so it's minus 4x plus 16. Does that make sense, how you get the minus 4x plus 16? You want to multiply 4 times minus x minus 4x, and 4 times 4 plus 16. Making more sense now? Here, why don't you try C? See if that makes sense. Okay, well let's try C and see what we get for that. What if we multiply 2 times minus 2x? Do you know what you would get if you multiply that part so far? So we're multiplying the 2 times the first term in the brackets. So what's 2 times minus 2x going to be? Remember, it's just like you multiply 2 times minus 2, and then you still have the x there, right? So what do you think that's going to be? 2 times minus 2x. If it was 2 times, sorry. Just notice you're typing. Okay, well, if it was 2 times minus 2, it's going to be minus 4, right? But since you have the x there, it's just minus 4x. Okay? Because remember, 2 times minus 2x is kind of like you're doubling minus 2x. It's kind of like having minus 2x and then another minus 2x. So it's minus 2x and then you're getting more negative. Okay? So 2 times minus 2x is minus 4x, and then you multiply 2 times 4, and you get 8. So this one would be minus 4x plus 8. And the last one here would just be 2 times 2x, well that would be 4x, and then you multiply the 2 times minus 4, and that's going to be minus 8. So it's going to be 4x minus 8. Okay? So, again, you want to multiply each one of these out and see which one gives you that minus 4x plus 16 that we said that this equals. Okay? So, let's go to the next one. All right, badminton. That is definitely one of my other favorite sports. I play it almost once a week at the Kinsman Center in Edmonton when it's not busy, which is a lot of times it is. So, this question here is talking about 5 players play each other. Everybody plays each other, right? And then after everybody plays each other, there's one final game. So the easiest way to do this is, since we know there's 5 players, we just make it A, B, C, D, E. And when we make them together in a circle, kind of a circle type, I know it's not exactly a circle, but you kind of make a line between each two. And then you just make sure that there's a line that connects between A and B, A and C, A and D, A and E. And you do the same thing for B. Just make sure it connects to each one of the other letters. When you do that, it happens to make a star, right? And so anyways, all you need to do to find out how many games are going to be played in all is count up all these lines That's going to be the total number of games. And then we have one playoff game at the end. So that's one extra game. If you count up all these lines, there should be 10 plus one final game. That would be 11 games. Okay? So if you have a different situation where you don't have 5 players playing, it's just different. You just, let's say you had 4, you would just set them up this way. And again, make sure everybody's connected to everybody else by a line. And then count the number of lines, add one more for the final game, and that's how you do it. Does that make sense? All right. Are you still with me, Matthew? Right on. Okay, so let's look at BEDMAS here. All right, so good old BEDMAS. Remember brackets, exponents, division or multiplication, then addition or subtraction, right? So with that in mind, looking at this question here, what's the first step we're going to take using BEDMAS? Which one of those letters? What does it stand for? Okay, it's going to be brackets first. So can you guys tell me, how about if, Ariel, could you tell me what we get when we simplify this bracket? And Matthew, can you tell me what we simplify when we get this bracket? Okay, so we got 6 here. And remember, when we have 2 minuses, that's just like a plus, right? We could just write a plus here. So what do you think that would equal? Minus 3 plus 4 would be plus 1. Okay. So just simplifying what we have so far, you can see we simplified this part, this bracket, we got 6. And here we had minus 3 minus 4, which is like minus 3 plus 4. That's going to be plus 1. Okay, so we've done the brackets so far, and then I'm just asking what's the next step? What do you guys think is going to be the next math operation? Are we going to do multiplication, division, addition, or subtraction using BEDMAS? Or you can just type the letter if you want. Okay, would you guys agree it's going to be division or multiplication? So we're going to do both these 2 multiplications, right? All right, so when we do that, we do this multiplication and we get 6. 3 times 4 is 12. And then we have this, where we just have addition and subtraction left. So we just do the addition first. 18 we're going to get, and then we do the subtraction. 18 minus 5 is going to give us 13. Okay, so that wasn't too bad, eh? Just keeping track of the BEDMAS stuff. All right, so here's one that might be a little bit more challenging. So this one says, a home builder is installing carpet in a new home. The area in square meters of the living room can be expressed as this here. Okay, so this is a trinomial. So it says if the length is represented by this amount, then the width is represented by what amount? Okay, so that's what we have to find out. So the question I have for you is, how are we going to use the area formula to help us solve this question? Okay, well, we know that area is always equal to length times width. So we're going to multiply this length by a mystery width, one of the ones that we're going to choose, and that's going to give us this area. Okay? So we're multiplying 2 binomials together to get this trinomial. So that's what we do. Length times width equals area. So I'm just showing that in the diagram. This missing width, we're going to multiply by this length and get this area. So how do we find out what the missing width is? Well, what we do is we're going to try multiplying one of these binomials times this x minus 3 and see if we end up getting this trinomial. So we just pick one of them. But do you guys remember what the name of that, okay, for lack of a better way of saying it, it's a 4-letter word, but not that kind, right? Okay, what is the four-letter math word we use to help us remember how we multiply two binomials together? Remember what that is? Okay, well, it's good old FOIL. Okay, so FOIL helps us remember it. So we're going to need to multiply these two binomials together and see if we get this here. So let's check out an example of doing one of them. So we're just choosing, for this example, we're just choosing b, x plus 5. We're going to multiply x plus 5 times the x minus 3 that we already had for the length, and we're going to see, does that give us this trinomial? So using FOIL, remember first means we multiply the first term in each bracket. That means going from left to right. What do you come across first? It's the x's. X times x is x squared. There we go. Now we do outer. That's the outer. This here, this x, and this minus 3 are outer. The way I always imagine getting the outer numbers in each bracket are if you take your hand and you spread it as far as it would go, which terms would you grab in each bracket? You would grab this one in this bracket and this one in this. X times minus 3 is the same as minus 3x. Okay? So that's what we get when we do O. I is inner. Again, if you put your hands close together, if you would imagine which things you would be grabbing from each bracket, you'd be grabbing the 5 and the x. 5 times x is 5x. Okay? Last, again, if first is the first thing you get going from left to right, last is the last term going from left to right. So it's 5 times minus 3. It's going to give us minus 15. So now we get all these terms. And we need to add them together. Okay, so we simplify minus 3x plus 5x is going to give us 2x. So we end up with x squared plus 2x minus 15. And that's our trinomial. But now we compare it to the trinomial we had, which was this one here. Are they the same? Nope, definitely not the same. So we chose the wrong one for b. So we need to try another one. So we just keep trying them until one of them is going to multiply to give us this amount right here. Okay, so does that make sense, guys? Okay, cool. Right on. So, next question here. So this one says, the calculator keystroke sequence that would give the solution of this here Okay, so this is the math problem here. So what kind of calculator sequence is going to solve this? Well, basically what you need to tell your calculator is that you want to divide all of this stuff on top by all of this stuff on bottom. The only way you can tell your calculator to do that is by putting brackets around what's on top and then brackets around what's on bottom. So if you put brackets around what's on top, I'm just going to show that. So first of all, if you were solving this question, you could actually put the brackets on the piece of paper, the test, and then you could just, that would be what your answer is going to be. That's exactly what you're going to tell your calculator. You're going to put these digits in, then you're going to press the divided symbol, and then you're going to put all of these digits in. So the answer that shows that is going to be this one right here, D. Okay, because it shows the brackets around what's on top. So you come to this point here, and then you have the divided by symbol that stands for the slash of the fraction, and then you've got a divided by on the bottom that goes around everything that you see on the bottom. Okay? So if you did those steps, that would actually be the correct solution on your calculator to solve this here. All right? Okay. Yeah, sometimes it does if it's really small or something like that. And I know it's a little bit cut off. You can't see everything here either. All right, so let's go to the next one. So next one here, we've got an equation, right? And whenever we have an equation that's got fractions in it, we don't like that, right? We got to get rid of those fractions. So the way to get rid of those fractions is to multiply by some number. So how do we find that number that we're going to multiply 3 and 9 by? Well, it's got to be the smallest number that both 3 and 9 will divide into. So now because 3 divides into 9, we can use 9 as the number we multiply by both. If we had like 3 and 4, then we couldn't do that. We need to multiply both by, say, 12, right? Okay, so we're going to multiply both sides of the fraction by 9, and that's going to get rid of these numbers in the fraction. But we have to do the same thing to both sides of the fraction, right? We need to multiply both sides by 9, and you can see that here in the red. Okay, so let's see what we get when we multiply everything by 9. When we have 9 multiplied by 3, that's like 9 over 3, which is the same thing as 3. So we have 3 times a gives us 3a. That's what we get when we do all this stuff here. Okay? When we multiply 9 over 9, that's the same as 1, right? 9 over 9 is 1. So we just have minus 1a or minus a. So we write that down, minus a. So we have 3a minus a. And on the right side, we're multiplying by 9. That's going to give us 36. 3a minus a is 2a equals 36. We solve that, and we get a equals 18. So that makes sense, guys, how we did that? We got rid of the fractions, why we chose 9, and then how these numbers kind of canceled out. Okay, right on. So let's go on to the next one. Next question here, we got Michael buying a fan for the cabin. So first of all, the store purchased the fan for $40, and then it's going to mark up the price by 15%. But after they mark up the price, then the fan goes on sale, and now it's decreased by 15%. So it says, what was the sale price? Okay, so here's the steps we do. First, we do a calculation to find the markup price. Then we do a calculation to find the sale price. Okay, so we ask ourselves, what percent was the original price marked up by? Well, that was 15%. And then what was the markup price marked down by? Well, that was also 15%. Okay, so let's see how that plays out. So first we found the markup price by finding the original price and adding 15%. Now notice when we add 15%, it's 15% of $40, right? Okay? Now of always means times in math, right? So it's 15% expressed as a decimal times the $40. And again, remember, percent always means divide by 100, right? So if we divide 15 by 100, we get 0.5. So that's why it's 0.5 times 40. Okay, so that's how we do this. And then this actual amount equals $6. We add it to the 40, and so we get $46. Okay, so that's how we get our markup price. And then that markup price is going to be reduced by 15%, and that's going to give us our sale price. So again, it's minus 0.5 times the $46, and that's going to boil down to $6.90. When we subtract that from 46, we get this amount here. So does that make sense, guys, how we do this part of the calculation here? Good stuff. Right on. So, okay, now we've got a question, and we've got some power rules that are going to have to be used. And so we've got this here, and it says x equals what? So how do we know what x equals? Well, what I can tell you is after we do the math, we're going to find out that we end up with x to the 6 equals 4,096. So what does that actually mean? X to the 6 equals 4,096. What it actually means is some number multiplied by itself 6 times is going to give us 4096. So we just need to find out what that some number is. And we can find out what it is by playing around with numbers, right? We could take 3 and multiply 3 by itself 6 times and see if that's 4,096. If it is, then the x equals 3, right? Or maybe x is going to be 4. Who knows? But you just keep trying numbers out, okay? So that's kind of what we're after. That's our overall goal of what we're doing in this problem. But now I want to show you how we get from this stuff with the x's to this answer here. Okay, so how we do that is, first of all, with the stuff in red, I am asking here, what do the exponent rules tell us to do to simplify what's in red? Okay, well again, we multiply the exponent inside the bracket times the one outside, and that's 3 times 3 is 9. Okay, So now we're going to have x to the 9, and I know this might look like a plus, but it's supposed to be divided by x to the 9 divided by x to the 3. Okay? So now we need to do another exponent rule to find out what that is. Remember, when we're dividing powers, we're going to subtract the exponents. That's how we find them. So it's going to be 9 minus 3. That's going to be 6. Okay? So now it's going to be x to the 6. And so that's how we end up with x to the 6 equals 4,096. Okay? So x to the 6 equals 4,096. So again, now we're going to plug in some numbers, try out 3, or 2 or whatever, multiply it 6 times, see if you get 4,096. If not, try another number. Okay? So does that kind of make sense? All right. So, next question here. So it says Alex runs on a treadmill and consumes about, that should be 4 times 10 to the 6. I didn't have it raised there. It should be 10 to the 6. So he consumes this much energy every 15 minutes. At this rate of energy consumption, if he runs for this many hours, the amount of energy he uses, expressed in scientific notation, is how much? Okay, so the question I'm asking first of all, as far as how we're going to use the info to get our formula, how are we going to find the total energy used if we know that he uses this much energy per 15 minutes? Okay, well, here's what we do. I'll go on to the next page. So if we know that he uses a certain amount of energy per 15 minutes, we can just write that out, energy used per 15 minutes. It makes sense that if you multiply that by the number of minutes, then the minutes are going to cancel out, because you have minutes on the bottom and on top. Minutes are going to cancel out, and you'll just be left with energy. So basically, you're trying to find some formula that's going to leave you with what you're trying to find. You're trying to find energy, so you take this energy used per 15 minutes. When you see every 15 minutes, that means divided by 15 minutes. So you take that and you know, okay, I'm going to multiply by number of minutes, and that will leave me with energy. And that's what I'm trying to find, how much energy he uses. Okay? So that's the overall formula we're using here. But what we need to do is, since we have hours and we have minutes, we need to change 1 2/3 hours. Okay, it's 1.67 hours. We need to change that into minutes. We know it's going to be more than 60 minutes. One way of doing it is just saying 60 minutes over hours. And because you have hours on bottom and hours on top, the hours cancel out, and that leaves you with minutes. Okay, so that's kind of one way you could do it. And so it's 100.2 minutes. So again, we expected it was going to be more than 60 minutes because it's 1.67 hours, right? Okay, so we got the number of hours, or rather the number of minutes. And so now we multiply using this formula, and we have minutes cancel out, and we're going to have this amount of energy times this. It gives us this big number here, and it said find it in scientific notation. So we put our decimal here, 2.67. We count the number of digits. There's going to be 7, so it's going to be 2.67 times 10 to the 7. So does that basically make sense, guys, the steps we use there? All right, good stuff. So let's see how we're doing for time here. We're about, I think we've been about an hour so far, and should be able to wrap it up. I know it's a little bit longer, and we started a little bit later as well. But we should be able to wrap it up in, say, the next 15 minutes or so. All right? Okay, so this one says, a surveyor's report states that a field being planted measures this many meters by this many meters. A farmer spreads seed at a rate of 3.5 kilograms for every 100 meters squared. Given that 1 ton equals 1,000 kilograms, how many tons of seed are needed to plant the entire field? Okay, so again, I just want to give you guys some focus questions to think about. So the first question is, what formula would involve kilograms over meters, kilograms per meter squared? Okay, remember when it says kilograms every 100 meters squared, that means the same thing as kilograms divided by meter squared. So how could you use that to create a formula that's going to let you find the number of kilograms of seed? Well, since you have kilograms on top and meters squared on bottom, if you multiply by meters squared, the meters squared is going to cancel out and you'll be left with kilograms, right? Once you find kilograms, then you can find ton using this, what you know here. Okay? So that's kind of looking at the formula that you need. And so now how are we going to find area? Because we're going to be multiplying this by area, which is meters squared, right? Well, if we multiply meters times meters, that gives us meters squared, right? So we're going to multiply these two numbers together to give us the meters squared. So we know we're going to have to do that. And then all we need to know as well is how we're going to find tons after we get the number of kilograms. Well, we know we're going to have to divide the number of kilograms by 1,000, and that's going to give us the number of tons. Okay, so that's just all kind of things we need to know to solve this problem. So then, okay, we said what formula do we need to find kilograms? We know we have kilograms per meter squared. We created that using this info. And then if we multiply them by meters squared, they cancel out and we're left with kilograms, which we want to find, or at least we want to find tons, right? So now how do we find area? Again, we multiply these two things. So where we have meters squared, we plug in the amount that we got. That's going to be this number that we got. So we're going to multiply this by this and divide by this, and we get this many kilograms. Okay? Now all we need to do is divide by 1,000, and that'll give us the number of tons. And that's going to be our last step. Okay? So did that kind of make sense, guys? How we reason it through, you know, what formula we needed to find, and you know, and how we were going to change from tons into kilograms and all that. Okay. All right, so this one here, we're going to simplify, and we need to simplify all these different things. We simplify numbers, we simplify x's, and we simplify y's. So when we simplify numbers, what are we going to get? We have minus 25 divided by minus 5. That's going to be 5, right? Okay, so here we go, 5. So now we go to the x's. When we simplify the x powers, what are we going to get? Well, we need to use the rule that says when we divide powers, we subtract their exponents. So we have x to the minus 6 minus 5. So it's like x to the minus 5 minus 5. So it's going to be x to the minus 10. Now remember, when we have x to the minus 10, we use that rule for changing negative powers into positive ones. So instead of x to the minus 10, I'll show you what we do. Okay, so we have x to the minus 10. We change it into a power with a positive 10, and then we divide 1 by that power. So that's what we have with the x's right now. Now let's look at the y's. Okay, so when we simplify the y's, we have y to the 4 minus 5, right? That's the math we're going to do. 4 minus 5, that gives us y to the minus 1. So let's use that rule for taking y to the minus 1. Okay, y to the minus 1 is going to be 1 over y to the positive 1. Okay? So now we've simplified numbers, x's, and y's. And let's see how we put them all together. Okay, well, when we simplified the numbers, we got 5. But since we have a fraction, we want to make that into 5 over 1. We put the 1 on the bottom, right? We don't really have to, but that way we just have something for everything. We had 1 over x to the 10. We had 1 over y to the 1. Now we just multiply all these things together. 5 times 1 times 1 is just 5. The 1 doesn't affect anything here, so we're just left with x to the 10, and y to the 1 is just y, right? So this is going to be our answer, simplified. So does that kind of make sense? We're getting close, guys. Pretty close. 26. We're just going to 29. All right. So we're talking about inequalities here. And you guys remember that when you solve inequalities, it's almost the same as solving an equation. So we just kind of ignore the inequality sign and we pretend it's an equation sign. So when we solve this then, we say, okay, I want just t's on the right side, but I have this 10 together with the variable term. I want to get rid of 10. So I need to subtract 10 from both sides as my first step. When I do that, I'm left with this on the left side and I'm left with just minus 4t on the right side. So now it's a lot more simple, right? Now, at this point, we say, okay, if I have minus 4t, what do I do to get rid of that minus 4? I divide by both sides by minus 4. So I should actually have a fraction symbol here. Now here's the catch though. Remember guys, when you divide an inequality by a negative number, or you multiply an inequality by a negative number, you have to switch the inequality sign. So instead of going in this direction, now all of a sudden it has to go in this direction. Okay? So really important rule to remember with inequalities. Okay? So now we're left with t on the right side, and we're left with minus 2 on the left side. So now we need to just find a graph that's showing us all numbers. So it says t is greater than or equal to negative 2. In other words, all numbers that are greater than 2 or equal to 2. Okay? So that's got to be a solid line because it's equal to 2 or greater. And since it's greater, the direction is going to go this way. Okay? So this one would be A. All right. So again, stop me if you have any questions, guys. So this next question, it says, a farmer and his son leave a barn at the same time and walk in the opposite direction, checking a fence line. The son walks at a speed of 3.5 kilometers an hour, the farmer at 4 kilometers an hour. How much time will have elapsed when the farmer and his son are 2.5 kilometers apart? Again, if you can ever draw a diagram, it helps to draw one, right? So here's the one that I drew. They're going in opposite directions. The son's going this speed, this way, farmer's going this way, and we're asking how much time when they get 2.5 kilometers apart. Okay? So we can set up a ratio. Remember, whenever you have a question that's got like 2 different units, like here we have speed and distance, you're probably going to end up setting up a ratio. Whenever you set up a ratio, okay, we'll just hold off on that for now. But first, let's look at stuff that we know. We know that in 1 hour, the farmer and the son have traveled 3.5 kilometers and 4 kilometers because the son travels 3.5 kilometers per hour, per 1 hour, and the farmer 4.4 kilometers, sorry, in 1 hour. So in 1 hour, they've traveled 3.5 plus 4, in other words, 7.5 kilometers, right? Okay, that can help us now to set up a ratio because we know that in 1 hour, they travel 7.5 kilometers in 1 hour, and we need to know how long it is for 2 kilometers. So 7.5 kilometers in 1 hour, 2.5 kilometers in X hours. So you always write out a sentence first before you ever do a ratio. So once you get that sentence, then you take this number and you put it over this number on one side of the equation, and you put this number over the other one on the other side. Okay. Well, thanks for coming, Ariel. And if you just want to read over the other ones later on, we should be done pretty soon on these. And so, yeah, thanks a lot for your participation. And yeah, have an awesome rest of the day. Okay, well, take care and talk to you later. Okay, so Matthew, we're getting close. You still with me? Okay, thanks a lot for hanging in here. It won't be too much longer. Okay, so we know that it's going to be 7.5 kilometers in 1 hour, 2.5 kilometers in X hours. So we set up this proportion, okay? And once we set up this, then we can solve it using cross-multiplying. 7.5 times X and 7.5X is equal to 2.5. Okay, so that's our equation. Then we just solve the equation for X. So I'm not actually going to do that there. You guys can continue with that. But that's the basic idea, since we've done that sort of thing in some other problems already. Okay, so this one, question 28, it says evaluate, and it's the same kind of deal as before. Substitution, the only difference is this time we're substituting 2 different numbers for 2 different variables, right? So when you do that, you just exactly plug in the number for the letter you're going to get this here, exactly, this first step. Then you just need to figure things out. So what's in the brackets? We have -2 and then -1. So we're negative, we're going more negative, so we're going to be -3 squared. In this bracket here, it's 1 minus -2. That's the same as 1 plus 2. So again, it's going to be 3 squared, right? So we're going to have -3 squared. That's going to be 9. -3 times -3 is 9. 3 times 3 is 9. Add those two 9s together, and you get 18. Okay, so this question just has a lot to do with keeping track of the the negatives and what's happening with them, and so that's what I was talking about here, this kind of stuff. Okay, so just practice this type of question until you can get it for sure. And we are on the very last question. All right, so this one here says, which of the following is not true about this trinomial? And so to figure this out, first of all, I just want to go over what's a constant and what's a coefficient. Okay, well, a constant is just a number that's on its own. It's just sitting there on its own, right? Whereas a coefficient is the number that's in front of a variable. Okay? So let's just look at A and B and see if they're true. Is 8 a constant? Yes, it is. It's just sitting there on its own. Is 6 a coefficient? Yes, it is. It's a number in front of a variable. So A and B are true. So it's got to be C or D. So this one says one of the factors is this, and this one says it's A equals -3. So let's figure out which one it is. So we're going to have to factor this trinomial. Now let's remember, how do we factor a trinomial? To factor a trinomial, we need to find two numbers that multiply to give us the last number, which is 8, and those same two numbers add to give us the middle number, which is 6. So what two numbers can we think of that multiply to give us 8 and add to give us 6? Okay, well, first of all, we take all the numbers and multiply to give us 8. We would write them down on a piece of paper, and we'd see that the two numbers 4 and 2 are going to multiply to give us 8, and they're going to add to give us 6. Okay, so that's why it's going to be A plus 2 and A plus 4. All right, so that'll help us find what the answer is. So it's either going to be C or D. And remember, if A plus 2 is one of the answers, A is actually equal to -2, right? Because you think of this bracket as equaling 0, so A equals -2, okay? So one of the factors is -2, the other one's going to be -4. So when we're looking at which of these is not true, we would say it's going to be A equals -3, because that wasn't one of our answers. All right. Well, hey, thanks a lot, Matthew, for hanging in to the end, and really appreciate it. So, again, try all these questions till you can get them all. If you have any questions at all, guys, please give me a shout, and keep up the hard work, guys, okay? And, again, the rewrite is on Thursday. Okay, so have an awesome day, guys, and hopefully you don't have too much snow shoveling like I have. We'll see you later, Matthew. Take care, eh? Okay, bye for now.